and welcome to this short video tutorial on gradient and intercept. In this tutorial we will look at how to determine the gradient and intercept of a straight line and a curve and how these features relate to the equation. You can pause, rewind and restart this video at any time by using the controls at the bottom of your screen. In English, the natural direction to read and write is from left to right. Think of the slope, or the gradient, as being a road that goes from left to right. Running uphill on such a road is hard going. If the road is flat, we can handle that easily, and if the road is downhill, it takes very little energy to run. Think of an uphill road as having a positive gradient, a flat road as having no gradient or zero gradient, and a downhill road as having a negative gradient. How steep the gradient is depends on how much up or down we travel compared to how far along we travel. The usual way to describe the gradient is rise over run, and this gives a measure of how steep the gradient is. In the first graph, to go from the start point to the end point, we must go 5 units along and then 2 units up. Evaluating the rise over the run gives a value of 2/5 or 0.4 for the gradient. In the second graph, which is much steeper, to go from the start to the end, it is 4 units along and 4 units up. Evaluating rise over run for this line gives a value of 1. The greater the value, the steeper the line. In the third graph, we go 5 units along, but then no units up or down. In other words, the rise is 0, so the gradient evaluates to 0. In the last graph, from the start to the end is 6 units along, and then instead of going up, it is 3 units down, or to put it another way, negative up. Evaluating rise over run for this gives a value of negative 0.5. The more negative the gradient, the steeper the downward slope of the line. If we choose any 2 points on this line, x1 and y1 and x2 and y2, the gain in height or rise in going from point 1 to point 2 will be the actual difference in the y values of these 2 points. And the horizontal distance from left to right, or the run, will be the actual difference in the x values of these 2 points. The rise over run can then be calculated. This conveys a formula for calculating the gradient of any straight line. All we need to do is to choose 2 points, calculate the difference in y values and the difference in x values, and divide. It is important to remember that the slope of a straight line is the same at every point along the line. The intercept is the point at which the line or curve crosses an axis. The x-intercept is where it cuts the x-axis and where the y value is 0. The y-intercept is where it cuts the y-axis and where the x value is 0. Here we have a graph of the equation y equals 0.5x minus 1. By choosing 2 points on the line, the gradient can be worked out to be 0.5. We can see that this is the value of the coefficient of the x in the equation. Also, the y-intercept is at 0, negative 1. That is, the line crosses the y-axis at negative 1. Which is the same as the constant term in the equation. Therefore, for the general equation of a straight line y equals mx plus b, the value of the gradient is m and the value of the y-intercept is b. When exploring the gradient of a curve, the problem is that the slope is not constant. It changes as we travel along the curve from left to right. So, how can we calculate the slope or gradient of a curve? The solution is that we can calculate the gradient of the curve at any particular point on the curve. This is done by drawing a tangent to the curve at the point where we want to calculate the slope, and then finding the gradient of that tangent. The gradient of the curve at that point, then, will be equal to the gradient of the straight line tangent to the curve at that point. We find the gradient of the tangent to the curve in the same way as we find the gradient of a straight line. On the graphs shown, several points have been selected, and the gradient to the curve at each one of those points is drawn. By choosing 2 points on each of these lines, it is possible, using the formula, to work out the gradient of each line and hence the gradient of the curve at each of those points. Here we have the graph of the straight line y equals negative 2/3 x plus 1. What are its gradient and y-intercept? From the general equation of a straight line, we can see that the gradient, m, is the coefficient of the x, and the value of b is the value of the y-intercept. Thus, the gradient is negative 2/3 and the y-intercept is 1. This can also be calculated graphically using the formula for gradient and observing where the line cuts the y-axis to give the value of the y-intercept. The fact that the line slopes downward from left to right also means that the gradient is negative. Here we have a graph of a straight line and we are being asked to work out its equation. It has a downward slope from left to right, so we know it will have a negative gradient. We observe that the line cuts the y-axis at negative 1.5, so the value of b in the equation will be negative 1.5. By selecting 2 points on the line and applying the formula, the gradient works out to be negative 1.5 also. So the equation of the line becomes y equals negative 1.5x minus 1.5.